Okay, so let's calculate our own BMR using the information that's given in your lab manual. So first thing you're going to do the first thing you're going to calculate is the BMR, the basal metabolic rate, the amount of energy that we need in order to just stay alive. So for that, we're going to go to this chart that's on page, what is that? Well, it says body surface area. Okay, so the directions say that you need to first find your height. Let's say you are 5'6". 5'6" is right here. So you're going to put a dot right there. And let's say you weigh 140 pounds. Then you are right here. Now, in order to calculate your surface area, you're going to have to draw a line between the dot that you put on the height bar and the dot that you put on the weight bar. So let's do that. So we're just going to draw a line here roughly from... Okay, so not too bad. So you're going to connect the height dot with the weight dot, and then you're going to cross over the surface area. And so we're going to cross over the surface area right here where it says 1.7. Now that data point is going to go into your chart right here. So your size in square meters was 1.7 square meters. Then you need to figure out what is the energy that you're using per your square meters, so your body size. For that, you need to go to another chart, and that is the next one right here, the Bioenergetics Chart. Let's say you are 25 years old, and let's say you are female. So we're going to go from 25 all the way down here, and we're arriving at 35.1. Of course, if you're male, then you're 38.4. So let's just wherever you fall. So just pick that number, and that number goes back into the chart on the 2 pages ahead. So let's go back those pages. So we had 35.1. We said 35.1. So these 35.1, they're going right here. 35.1. Then we need to multiply that times 24. Let's do that real quick. So that's 1.7 for the body size times 35.1 times 24 is equal to, I'm going to round to the nearest full calorie, and that would be 1,432 calories. So that number says that based on your size and your gender and your height, so your overall size and your gender, you need 1,432 calories just to stay alive. So even if you don't do anything, you need that amount of calories per day to just stay alive and give your body what it needs to stay alive. Okay. Now, we need to add to that number how much we're going to use our muscles. So in other words, what's your activity level? A good default activity level, sort of an average, is 0.5. So of course, if you were working out every day, I don't know, 5-6 hours, you need more energy, I'm sure. Right now, we probably use less energy, but let's just estimate our voluntary muscle energy expenditure at 0.5. So it's 0.5 of your BMR, and that BMR was 1,432 calories. So now we multiply 1,432 times 0.5, and that gives us 716 kilocalories that we would need to add to our diet in order to have enough energy for our muscle activity. And then we need the specific dynamic action, and that is 10% of your BMR plus VMA combined. So you're going to take your BMR number, which was 1,432, plus the VMA, that is kilocalories times 0.1, and that turns out to be, let's calculate that, 716 plus 1432 is equal to 2148 times 0.1, 10% of that, so that's 214. So I'm going to round off to the nearest full calorie. That's 215 calories. Now we need to add all of this together, so we're going to have 1,432 plus 716 plus 215, and that's equal to 2,363, and that goes into this page right here. So that's 2,363, and that's just for my example. You use your own numbers, calculate it for yourself. This is sort of an estimate of the daily energy need in order to have your body do what it needs to do to stay alive, have you move around whichever way you like, and digest your food so you have some energy. Okay, so we have 1432 plus, then we had 716 plus 215, and that comes out to 2363. That is the amount of kilocalories or big calories that you need in order to stay to do all your activities. So your daily energy need. Now the question is, how much are you eating? Well, that is something you could figure out, and you should. And there are some pages in the lab manual. Let me just find that. Okay, so I scrolled down quite a few pages, and I'm here in the data report section of your lab manual, and there are 3 days worth of energy intake that you're supposed to record, and you should definitely do that. I'm going to talk about that in just a minute, but let's go down to the bottom of the 3rd day. And so here goes the numbers that we just calculated. And so we had a basal metabolic rate in our example that was 1,432, and you use your own data. Calculate that. Voluntary muscle activity was 716, and specific dynamic action is 215, and that was that would be your average. That would be what you supposedly need. Now, so that adds up to, that was, our number was 2,363. And then you're supposed to calculate how much are you actually taking in. And so for that, you should do a 3-day average. Try your best and record what you're eating for breakfast, for lunch, for dinner, for snacks and other things, and figure out how many calories am I actually taking in. And so that total then goes on the bottom here. That's your day 1. So you can start tomorrow. And then on day 2, you're going to record what you're going to eat for breakfast, what you're eating for lunch, for dinner, and so forth. And for snacks and other things, your total goes right here. And then you have day 3, and that will be recorded here. You just look at the food labels as much as you can. There's also a bunch of apps out there that will help you calculate approximately how many calories you're taking in, but since we have nothing to do all day anyway, so might as well just do that. So figure out how many calories you are eating when you're eating something, and record that in your lab journal for lab 4. And here are some suggestions. There are some apps and websites, a calorie counter, that's a good one. And then there's tons of apps that you can use on your phone too. So try to do that. You would have to do this at home anyway, so we don't even need a lab for that. But just go ahead and fill out these 3 worksheets for 3 days worth of energy intake, and then add up the 3 days, the total for each day, and divide by 3, and that will give you the average daily calorie intake that you're actually eating in, and then you figure out what's the difference, if any. And obviously, if you are taking in a lot more calories than what you're needing, than what you're spending, then over time you will gain weight. If you are taking in fewer calories than you're spending, then you lose weight over time. Okay, and now here, the fitness test results. So here, let me just guide you through some of the stuff that you can do at home. The Skinfold measurement, you probably will not be able to do unless you have some sort of one of those fat thickness measurements. So that's basically you're measuring on different body parts. There's a nice little write-up showing you pictures of where you're supposed to measure. That's the subcutaneous fat, and it's an indicator of your overall fat. So you're supposed to measure sort of how thick is your fat layer under the skin, and that adds up, and then you can estimate your body fat percentage with that. You can also use the waist to hip ratio measurement and compare that to the BMI. So you can measure your waist circumference, record your data right here, here, and right here. And you can calculate your BMI. That's your weight in kilograms divided by your height in square meters. I'm sorry, your height in meters, and that's squared. So there are some charts out there. I don't think we have one in the lab manual, but there's some charts out there where you can then compare sort of where you're falling, your BMI, your body mass index, and you can compare that to your measurements of waist circumference and then a waist to hip ratio. Both of them are estimates of your overall body composition. And here there are some, is a table that shows you sort of some guidelines for body mass index, what that's supposed to be. So again, the body mass index is calculated by taking your weight in kilograms. If you forgot how to calculate kilograms, you take your pounds, your weight in pounds, and divide by 2.2. And your height in meters, I think you guys all should know this because we did some measurements on that. So if you know just the centimeter, so you know, let's say you know your inches, you multiply the inches times 2.54, and then you set the decimal point 2 places to the left. So let's say you calculated, let's say you're 60 inches tall times 2.54. That's equal to, let's see, 60 times 2.54. That's equal to 152, just round to the nearest centimeter. Then you need to move the decimal 2 places to the left, and there you are, 1.52 meters. That's your height in meters. You would have to square that number, and you need to divide your weight in kilograms. Let's say you're weighing 60 kilograms, and then you divide by 1.52 squared, and that will give you your body mass index. And these are just examples, so try to use your own numbers, please. Here are some guidelines for classification into underweight, normal weight, overweight, and obesity by class 1, 2, and 3, with class 3 obesity would be morbidly obese. That means it's affecting your health to the point where it's really shortening your life. Then here are the reach test flexibility guidelines. That is something you could easily do as long as you have some sort of a tape measure. You can easily follow the guidelines and see where you fall with your flexibility. And hey, it's never a bad thing to work on your flexibility, so you should do that. It's a sit and reach test, can be easily done at home. And then your test for cardiovascular fitness, you should measure your pulse. You can either do your pulse at your wrist, or you can do your carotid pulse. You can measure either for 15 seconds and multiply times 4, or do 30-second recording and then multiply times 2 to get your per minute pulse rate or heart rate. And you can record your own results on that based on the instructions given. Your standing pulse rate, try to record that, and pulse rate increase when you're standing up from a sitting position. All of that can easily be done at home, so have some fun with that. Do this lab at home. And here would be pulse rate immediately after exercise. So this is this Harvard step testing. You transfer your normal standing pulse rate, and then you have your